This is Precalc, Section 3.8, Polynomial Equations and Inequalities. We are asked to solve this equation using the zero products property, which is saying to us we need to factor this. Since there are four terms, we want to factor by grouping. I can take an x squared out of the first two terms, leaving x plus 3 behind, minus 4, which is the GCF. And when you divide these last two terms by negative 4, you get x plus 3 in the parentheses. And you know for factoring by grouping to continue, what's in the parentheses must match, and it does. I always bring it out front. And what goes in the other parentheses is x squared minus 4 equals 0. Oftentimes when you solve by grouping, you're finished right here. But x squared minus 4 continues to factor. X squared minus 4 is the difference of two squares. It factors as x plus 2 times x minus 2 equals 0. Which means we have three solutions. You can set each one of these equal to 0. And our solutions are negative 3, negative 2, positive 2. Now, the next thing we're asked to do is graph that polynomial, and that's a screen clipping of that graph. To tie this in with what we did in the last section, notice that our curve crosses the axis in three places. It crosses here, here, and here. And we know what those intercepts are because we have these solutions. This one over here is negative 3, this one right here is negative 2, and this one here is positive 2. Now, this is asking us to use this graph to solve these inequalities. In college algebra, we solve these inequalities by putting the numbers on a number line, negative 3, negative 2, positive 2, and then doing test points from each of these regions. Well, this is asking us to do it graphically, which is a lot easier. We look here and we want to know greater than 0. What this is saying is we're looking for where is the curve above the x-axis. So look at your picture and you can see we are above the x-axis in here and all of this over here. So we're asked to write in interval notation what those intervals are. So it is above the axis between negative 3 and negative 2. It is above the axis to the right of 2. Now you need to be careful about this being parentheses, and the reason this is parentheses rather than the bracket is that this sign right here is just greater than 0. At negative 3, it is actually equal to 0, and that's why we're using the parentheses. When we do this one here, which is less than or equal to 0, less than or equal to 0 occurs here. I didn't do a very good job of coloring that. All of this. So I've got two regions where it is less than or equal to 0. This is less than or equal to 0. So on the left side here, all of this goes from negative infinity up to this point right here, which is negative 3, which gets a bracket this time because this is less than or equal to, union with all of this underneath here, which is from negative 2 to 2. Both of those getting the bracket because it is less than or equal to 0. Besides doing inequalities, we are also solving some regular polynomial equations that we have already done before. This we can solve by factoring. Take out a GCF of x, which gives us 4x squared plus 17x plus 4 equals 0. This trinomial right here will factor again with 4x and x in the front plus 1 plus 4, which gives us the 17 in the middle if you FOIL that out. Set each of those factors equal to 0, and we get x equals 0, negative 1/4, negative 4. So there are our three real solutions. Same directions, find the real solutions. The factoring here is a little bit different because this is four terms, and you know we're going to factor by grouping. Take an n squared out of the first part. All I can take out of here is a negative 1, which gives me n minus 2 in the parentheses. Bring the n minus 2, which is in common inside the parentheses out front. And what's in your other parentheses is n squared minus 1. The n squared minus 1 is the difference of two squares, which factors as n plus 1, n minus 1. Set each of these equal to 0 and solve, and you get n equals 2, negative 1, and 1. All of those are real solutions. Solve this. Now, you know when you solve, you need to have everything on one side in descending order equal to 0. So subtract x squared from both sides. Also subtract 8 from both sides. I'll squeeze that in right there. Be careful with your arithmetic. Negative x squared and negative x squared do not cancel out. They are both negative. So it's negative 1 gives me negative 2x squared minus 8 equals 0. Now the way I do this is I consider this in quadratic form. It's not an actual quadratic because the lead power here is 4. To be an actual quadratic, it would need to be squared. But it's quadratic form, and you know you have quadratic form when the lead power, which is 4, is exactly twice your middle power, which says I can just kind of pretend a little bit and still factor this as if it were a quadratic. But the difference is I will not put x in the front. I will put x squared in the front. Two reasons I put x squared in the front. Easy reason is whatever the middle power is, once you have decided it's quadratic form, which it is, whatever the middle power is goes in the front. And the reason that works is if you do x squared times x squared, you get x to the 4th. The signs will be 1 plus, 1 minus, and what you're saying to yourself here is what multiplies to give me 8, that subtracts to give me 2, which would be 4 and 2. Now the x squared plus 2 will not factor any further. X squared minus 4 does factor as x minus 2 times x plus 2 because it's the difference of two squares. Set each one equal to 0. Now normally I don't show the setting equal to 0 and we just do the solving in our head. But with this one I do need to set it equal to 0 and show you something. This is x squared plus 2 equals 0. The only way I'm going to solve this is to subtract 2 from both sides, undo the squared by taking the square root, and as soon as you take the square root, you're looking at plus or minus I radical 2. That's not a real solution, so that's going to get thrown out. I really didn't even need to simplify this down to I radical 2. As soon as you took the square root of a negative there, you knew you were going to get imaginaries. These two do produce real numbers, 2 and negative 2. So I only get 2 solutions. This is a new theorem that we have not seen before. It's called the complex nth roots of a number theorem. And it says if n is a positive integer and k is a non-zero complex number, then the equation x to the n equals k has exactly n complex roots. X to the n equals k, which is exactly what this is. This is x to the n, in this case 4, equals k, which is 256. Without this theorem, without knowing that there are n complex roots, you might be tempted to take this and just say, hey, let's just take the 4th root of both sides. Because, you know, if we're going to undo x to the 4th, do the opposite, which is the 4th root. Well, if you do the 4th root of 256, you're not going to find all of the solutions. So to find all of the solutions, we must do this by factoring. Subtract 256 from both sides. I have x to the 4th minus 256 equals 0. That is the difference of two squares. So it's x squared in the front, plus, minus, and the number that's squared that gives me 256 is 16. X squared plus 16 will not factor any further, but x squared minus 16 does. It is also the difference of two squares. X plus 4 times x minus 4. Set each of these equal to 0 and solve. Now that you can do in your head, you get negative 4. That one you can do in your head, you get positive 4. This one, though, I need to show a little bit of work. Set that equal to 0. Subtract 16 from both sides and solve by taking the square root. Unlike the last problem, this is not asking me to throw out the non-reals. This says find all complex roots. So I keep on going with the square root of a negative. So this is x equals plus or minus 4i. So there are my 4 roots. The theorem told me there should be 4 roots. If we have x to the n equals k, n is a positive integer, it has exactly n complex roots. X to the 4th should have 4 complex roots, plus or minus 4i, negative 4, and 4. Keep in mind, negative 4 and 4 are real numbers, but they are part of the complex number system. You could think of negative 4 as negative 4 plus 0i if you wanted to, and that's why it's considered a complex root.